We are back with some mixture problems of systems of equations. So these are word problems. We have a jeweler that mixes an alloy with 16% gold content and an alloy of 28% gold content to attain 32 ounces of a new alloy with 25% gold content. We're looking about how many ounces for each of these original alloys is what we're looking for. So we're going to start off with our equations. So we are going to start off with X being the 16% alloy, and then we're going to do Y being the 28% alloy. And it doesn't matter which one you choose to be which, that's the one I chose. So that doesn't matter if you do anything else different. So when we're looking at the first one, we are going to be combining the two different types of gold alloys, and we want to get a total of 32 ounces. So that's going to add up to 32 ounces. Now we have to deal with the percentages for each of the contents. So the X content is 0.16. We want to use that percentage as a decimal. And then our Y is 28%. So we're going to add that 0.28Y. Now we're looking to get a 25% alloy content. So we do need to still use that 32 ounces that we are looking to get. But we're going to multiply it times 0.25 because we want to get that content, and it has to be 25%. So now what we're going to end up doing is we'll start off by evaluating just that 25% of 32. That's going to give me 0.16x. We didn't do anything to the beginning of this, so then we have 0.28y. We're just changing this part right here. So when I actually evaluate that, I get 8. And then we're going to change the top equation. I'm going to do elimination method. So I'm going to multiply this entire top equation by a negative 0.16. You could use simplification of substituting if you wanted to do that. That works too, but this is just the way I'm going to go with it. So X and Y are going to both be negative 0.16 in front of it because when you're multiplying the distributive property, you're just going to end up with this. So that would give you those two, and then when I multiply the negative 0.16 times 32, I end up with a negative 5.12. Now, we are going to end up with some negative answers that, and throughout the problem, and that's okay, because when we end up evening everything out at the end, it'll be fine. Adding together, these two will cancel. When we add these two together, we have a negative 0.16 and a 0.28y. That adds up to be a positive 0.12y. Here we have the negative 5.12, but we're adding it to 8, so that still ends up making this one positive, which is 2.88. Last step, divide both sides by 0.12, and we will get y equaling 24. So that means that in that particular section, we have 24 ounces of the Y, which is the 28% alloy. So this is going to be OZ of the 28%. So that's that part. And then we're going to go ahead and sub it back in. That's the Y. So we have 24 for the Y. We want to add whatever our X is to get us 32 ounces. Subtract both sides by the 24, leaving me with the X equaling 8. So it's 8 ounces of, in this case, the 16% alloy. And that would be my answer. We have 8 ounces of 16% alloy with 24 ounces of the 28% alloy. And if you want more questions like this, find them on my YouTube. You want algebra, check them out under the system of equations section.